Hello everyone. Today I am going to solve the tutorial of fluid and particle mechanics, and the topic is filtration. So first I am going to solve the first question. The first question consists of first I am going to read the question. Laboratory filtration conduct at a constant pressure drop on slurry of calcium carbonate in H2O gave the data shown in the table. Table is given here. Volume, time and T by V. The filtrate area is given 0.044 meter square. The mass of solid per unit volume of filtrate is given 23.5 gram per liter, and temperature is given. The viscosity of water is 0.886 centipoise, and pressure drop is given. In the question they have mentioned that the pressure drop is constant throughout the process, and the pressure drop is 46194.8 Newton per meter square. So first I am going to convert all the data in 1 unit. So here I am going to convert all the data in food pond system units. So for first I am going with the area, filtrate area. Area equal to 0.044 meter square equal to 0.044 divided by 0.3048 square equal to 0.474 foot square. Similar to that, concentrate of filtrate is given 23.5 gram per liter. In FPF it will be 23.5, 28.31 divided by 454 is equal to 1.47 pound per feet cube. Similar to viscosity of water equal to 0.886 centipoise equal to 5.95 into 10 power minus 4 pound per foot second. And for the pressure drop also, delta P equal to 46194.8 Newton per meter square. In food pond system it will be 31073 lb per foot second. So in the question the data table is given that with respect to volume. I am going to make the table also. Filtrate volume, time in second, and T by V. 0.5, 1, 1.5, 2, 2.5 and 3. Okay. And time is 17.3, 41.3, 72.0, 108.3, 152.1, 201.7, and T by V is given 34.6, 41.3, 48, 54.15, 60.84 and 67.23. So in the question they have mentioned it is a constant pressure drop problem. So for that there is a equation T, it is for constant filter process equation is T by V equal to Kc by 2 into V plus 1 by Q naught. So, if we plot T versus V versus this is a equation of a straight line where intercept is 1 by Q naught and Kc by 2 is the slope. So, I am going to do a rough plot for this. T by V versus volume 1, 2, 3, 4, 5 and 10, 20, 30, 40, 50, 60, 70. So, if you plot this T versus V, it will give you a straight line. Similar to that. This is the unit in second per liter. This volume is in liter. Later, after getting the intercept and slope, I will convert in the same foot pound unit system. So, from the graph we will get intercept equal to 28.21 second per liter and slope equal to 13.02. So, in here intercept is normally is equal to 1 by Q naught from that equation and equal to 28.21. In foot pound system it will be about 800 second per feet cube. Coming to the slope part, slope equal to Kc by 2 equal to 13.02. In foot pound system it will be 10440 second per feet cube. And now I am going to apply the same constant pressure formula. So, the equation was T by V equal to Kc by 2 into V plus 1 by Q naught, where Kc is equal to mu C alpha into area square to pressure drop. Here mu is viscosity and C is the concentration. So, now everything is known except this alpha. Alpha is a specific cake resistance that we have to find out. So, alpha equal to area square delta P Kc by mu into C. Okay. So, yeah, okay, I need to cut this video. Okay, just put the slope part Kc by 2 equal to 10440 into 2 equal to 5.95 into 10 power minus 4 into 1.47 into alpha divided by 0.474 area square into pressure drop 31073. So, you will get a specific cake resistance equal to 1.66 into 10 power 11 foot per unit pound. This is the first part. In the Second part I have to find cake resistance, that is from the slope. We got the slope equal to intercept equal to 800 second per feet cube and equal to this one mu Rm cake resistance into area into pressure drop. So, everything is known here, just put the value. 800 equal to mu is 5.95 into 10 power minus 4 Rm divided by 0.474 into 31073. So, you will get Rm equal to 1.98 into 10 power 10 foot inverse. This is the first part of first question. Now, I am coming to the second question. Second question is the just the extension of the first question. Here in the second question only the pressure drop is not constant, pressure drop is varying with respect to specific resistance. So, in the in this question there is table is given, pressure in this question table is given. Second question, okay, versus pressure drop, filter resistance and specific filter resistance alpha. This table are given. So, okay. So, I am going to plot the graph Rm versus delta P. It will show how the cake resistance vary with the pressure. So, if you plot this graph, it will come to the straight line. From this graph, from the graph, we can say that the filter medium resistance is linearly varying with pressure. This is the but the total pressure rise, but the total pressure rise is only 50% of initial resistance. But in this case, if you see the table, pressure rise is almost 6 to 7 times from the initial value. In the second part, from the table, I am going to plot the log. I am going to plot log plot of alpha versus pressure drop. So, I am going just giving the rough plot here, log alpha log delta P. So it will come similar to a straight line if you fit the point. So from this equation the slope from this plot, the slope will give the value of S. For varying pressure drop, the cake is not incompressible. Oh, sorry. Okay. Oh, sorry. This S is the compressibility factor of the cake. Okay. So this equation will be suitable, alpha equal to alpha naught into delta p raised to power s, where alpha naught and s is empirical constant. Normally s for s equal to 0, cake is incompressible, and for normally the value of s vary from 0.2 to 0.8. For s is being positive, the cake will be compressible. So from this plot you will get s equal to 0.25. So from this we can conclude that the slope of the plot is given s, and this is slightly compressible. The value of s is about 0.25. So the cake is not that much compressible, it is slightly compressible. Now I am going to solve the third question of this tutorial. In the third question, a leaf filter has an area of 0.5 meter square and operate at a constant pressure drop of 500 kilopascal. The following test results were obtained for slurry in water, which gave rise into a filter cake. The table is given here: volume versus time, (0.1), 0.2, 0.3, 0.4, 0.5, 140 second meter cube, 360, 660, 040, 1500. This is also a constant pressure drop problem. So we are going to apply the same equation as in the first one. So for that we need the value of t versus v for plotting the graph. So if you just calculate the t versus v, you will get this one is 1400, this one you will get 1800, 2200, 2600, 3000. So we are going to apply the same formula, t versus v equal to kc by 2 into v plus 1 by q naught, where kc is equal to mu c alpha divided by a square delta p, and 1 by q naught equal to mu rm by a into delta p. So I am going to do a rough plot for this. This one is volume, this is time versus time by volume. volume 0.1, 0.2, 0.3, 0.4, 0.5. So here if you plot the graph, you will also you will get the same straight line. So from the graph, the slope, if you calculate the slope, you will get slope equal to 4000 second per meter 6 and intercept equal to 1000 second per meter cube. So for the first, even I am throwing the question, area is given equal to 0.5 meter square, and in the first case the constant pressure then drop is 500 kilopascal equal to 500 to 10 power 3 Pascal. So coming to the intercept part, 1 by q naught equal to mu rm by a into delta p. So from this equation I am going to calculate mu rm equal to 1 by q naught was 1000 into area is 0.5 meter square into pressure of 500 into 10 power 3. So you will get mu rm equal to 2.5 into 10 power 7. So from the slope part, Kc equal to mu c alpha by a square delta p. So from this equation I am going to calculate mu c alpha equal to 4000 into 0.5 square 500 into 10 power 3. It will give the value of 1 into 10 power 9 Pascal second per meter square. In the question they have asked to calculate the time need to collect 0.8 meter cube of filtrate at a constant pressure drop of 700 kilopascal. So again in the question they have asked to calculate a constant pressure drop of 700 kilopascal to 700 into 10 power 3 Pascal. So we will apply the same formula. T versus V equal to Kc by 2 into V plus 1 by q naught equal to mu c alpha by 2a square delta p. Just I am putting the value of Kc here and value of q naught mu alpha rm into a into delta p. So now everything is known, just we need to calculate the time to calculate the field rate of 0.8 meter cube. 1 into 10 power raised to 9 into 0.8 square 2 into 0.5 square into 700 into 10 power 3 plus 2.5 into 10 raised to 7 into 0.8 0.5 into 700 into 10 raised to 3. So it will come about 1828.1 plus 571.42 second equal to 2400 second equal to 40 minutes. This is the time required to calculate the about 0.8 meter cube of the filtrate. Now, the fourth question. In the fourth question, there is one plot, given plot is there. Red 150 5 10 15 20 25. Okay. This is filtrate volume in ml, and this is time versus volume in second per ml. So, in this question, the given data are pressure drop is given 10 power 5 Newton per meter square, filtrate area equal to 20 cm square, viscosity is given 0.001 Pascal second, mass of the cake 24.3 gram, volume of the filtrate equal to 154 cm cube. They have asked what is the filter medium resistance and filter cake resistance. So, this is also a constant pressure drop questions. I am going to apply the same equation here also. So, from the graph intercept is about 3.2 second per ml. In SI unit it will be 3.2 into 10 power 6 second per meter 6, and slope will be if you calculate it, it will come about 0.21. In SI unit it will be 10 power 12 second per meter 6. So, from the slope 0.21 into 10 power 12 second per meter 6. So, from the intercept part, one by q naught is equal to 3.12, sorry, it was 3.2 into 10 power 6 equal to mu Rm by into delta P. Here everything is known, viscosity, just I have to calculate the filter medium resistance Rm. So, Rm is equal to 3.2 into 10 power 6 into area is given 20 in meter, it will be 20 in 10 power minus 4 into delta P 10 power raised to 5 divided by mu will be 0.001. So Rm will come 6.4 into 10 to the power 11 meter inverse. This is filter medium resistance. Coming to slope was given Kc by 2 equal to mu c alpha a square delta p. Slope we have got from the graph is 0.21 into 10 raised to power 12 to 2 equal to, everything else is given 0.001. C is mass of the cake is given 24.3 and volume of the filter is given. From that we can get the concentration. In SI unit I have to multiply it by 1000 into alpha divided by area square 20 into 10 raised to power minus 4 square into pressure drop 5. So from the calculation it will come alpha equal to 5.3 into 10 raised to 11 meter per kg. Thank you.